Hey guys, Charlie here. Welcome back to another video. Today I'm going to be building a simple C++ Windows keylogger that will basically just log keystrokes to a file. This video is for educational purposes only. Don't use this maliciously. I just think it's a really good project for people to work on and kind of learn about. A little disclaimer, I am a student. I decided to build this project to learn. I believe that teaching somebody something that you learned helps to solidify it in your own brain. I'm not a professional programmer. I am a student. I am not responsible for any misuse of this code. If I explain something incorrectly, please leave a comment and I will do my best to learn from it and correct it in the video. Okay, just to start out, I'm going to do an extremely simple keylogger in Python so you understand the general idea and so we can kind of relate it to C++. It's just a couple lines, you'll see. What a keylogger basically does is it listens for keyboard events and just logs them to a file. That simple, just exactly how it sounds. Python makes this so much easier than C++ because we don't have to deal with Windows API directly. The py input, which I'll show you here, this library handles all of that for us. To get this, you just have to type pip install py input, and it should go ahead and install it. I already have it, but that's how you could do it. You do have to have Python installed. I'm on Python 3.13.9. Don't laugh at me using one dash. So yeah, make sure you have Python installed. Very basic stuff installing that. You can look up a YouTube tutorial if you're struggling a little bit, no problem. Okay, and for py input, we only need parts of the keyboard. We aren't looking for any other part of the Windows API. So we can go ahead and import listener and key, right? So basically listener, it's exactly what it sounds like. It's what listens for keyboard events. You can kind of see here. But basically this listener is kind of like the hook we'll get to later in C++, which is why I'm showing it to you. And then the key, it just gives us the constants for like special keys, like the enter key, the space key, etc. All right, we're gonna go ahead and define the function. Name doesn't matter, obviously, but we're gonna give it the parameter key. So first, let's print the key to console, like what they press. So literally just basic key pressed, right? And then key. The reason we're using a printf statement here is adding the f simply just allows us to use variables inside of this print statement. Okay, next, this is where it gets a little more into Python if you haven't. Essentially what we want to do is we want to save this key to the file, right? So what we can do is we can do with open, and then we need a file name, so python keylog.txt, right? And then a as f. Okay, so basically what this is doing is this is the file name. With open, it's just Python's like way, like it's their internal way, whatever, of opening files. And then this A means append mode. Okay, so basically what appending is you have a bunch of data in here, right? So somebody typed A 5 times. It's not exactly how it looked, but if it was, somebody typed A 5 times. If you launch the program and you don't have it in append mode, it literally just writes this file. It would just start overwriting this. But if you have your 5 A's and then you have append mode on, if they start typing more, it'll just add to this file rather than resetting it. All right, next we need to write the string to the file. What string key does is it converts the key to a string so that we can actually write it. And then just so this keeps listening, we can just return true. Okay, now we have like the actual like logic done there, right? But we have to start the keylogger. So we can just create the listener here with listener on press, which would be our function pressed. Well, I guess the proper term for this is context manager. And then all we have to do here is we just have to do listener.join. So this will literally just keep continuously run the program and keep listening for keys. So now if we go ahead and we run it up here, then we give it a second to load. All right, so if we look here, right, anything I do, it'll kind of just, it'll just monitor and it'll put it down here. But yeah, in 12 lines, there you go, there's a Python keylogger. And then here's what it would kind of look like in the keylog file. It's 12 lines. There's no formatting or anything. It's just straightforward, just all of this over and over. It's a little messy. Hopefully that Python keylogger can help you in some sort of way. But now we're going to go to what you really came here for, which is the C++ keylogger. I'm going to try and explain this as well as I can. I'm sure I'm going to miss some things, so just keep that in mind. But yeah. Before we actually start writing any code, we need to include the libraries that provide the functions and data types we'll be using. I have obviously written this keylogger before making this video, so I'm going to be doing what I remember and then following my script. Basically, I'm sure you guys have seen these includes, so like iostream, for example, which is like the most common one for C++. Basically, what this is saying is it is telling the compiler, like, I want to use tools from this library, right? So IO stream we actually will eventually need, but we can start. We need Windows. We need the Windows API, right? This is the most important header for Windows programming by far. It gives us pretty much everything to do with Windows. It's similar to the PyInput. And without this header, we literally can't interact with Windows at a low level at all. So necessary for Windows, right? Next, we can do file stream operations. This handles like opening, writing, and closing files, and just everything there, right? IO stream is the input-output stream. Basically what this does is it provides like, so you can have messages appear in your terminal. Next, we need string operations. So what this does, it allows us to utilize the string class. This lets us work with text really easily. So like concatenation, comparison, etc., which is very important. We also need time operations, which allows us to get and format time. And then we also need iomanip. Basically, this just helps provide formatting functions, which you'll see how we use it in the future. Okay, now we're going to go on to global variables. Global variables basically are accessible anywhere inside of the keylogger. We have them here because the multiple functions need to access the same file and hook handle. So first, what we're going to need is our file stream object. So we're gonna, because we're in the end, like this, what this does is it represents like the connection to our log file. We're gonna open this, we're gonna write to it, we're gonna close it repeatedly throughout the program over and over. We're also going to need a place to store the ID of our keyboard hook. We need to store it so we can later uninstall it when the program exits, which I'll show you guys later. And we also want to track whether or not it's the first keystroke of the session, right? So track whether it is the first keystroke of the session. And we can just use a boolean because it's just going to be a true or a false. All right, next we're going to get our formatted time helper. So we can use that string class and then get formatted time is what we'll call it. Basically, we need this function so that we can get the current time and format it as a string, right? So we can use it later in our program. So first, we are going to need to store the current time in a variable. I'm just going to use time t. The problem with this, however, is this is just going to be in raw seconds since like 1970. Like that is going to be such a large number, right? So we need to convert this to something that's more human readable with what's called a TM structure. So it's going to have years, month, days, hours, minutes, etc. So we need to create a structure, and we can just call it time info, very basic. And then we need to convert time t to that structure, which we can do local time and time info. And now, right? Basically, local time is very common. The _s just means secure, so it can prevent things like a buffer overflow. I assume you guys have had plenty of experience in C++ if you're watching this video. If you haven't, if you need to learn the nitty-gritty on some of this stuff, there's a ton of videos and documentation out there. So like if you don't understand like what a struct is, then simple Google search. I don't have time in this video, unfortunately, to explain it all. If you want me to, leave a comment. I'll happily reply to your comment. All right, and then next we're gonna need an array to store this formatted string, right? So I'm gonna create a character array, and 20 characters is gonna be plenty. And then we need to format and print the time, right? So string f time is basically just like printf but for time. So basically what this is doing is it is taking the time that is stored here in time info and it's putting it into buffer in this format. And then it's also, we just want to make sure that there's no overflow. So, all right. And then we need to convert the C style string to a C++ string and then return it so that we are able to use it later. All right. Now time for literally the longest and most annoying part, but also the core. Basically, it's going to be called by Windows whenever a key is pressed. So it'll receive a virtual key code and process it, and then it'll log the keystroke in the log file, and then Windows. So basically, Windows doesn't use letters internally, right? Instead, each key has a numeric code. It's called a virtual key code. So, like for example, 0x41 is equal to A. That's just how Windows does it. It's fantastic. So what we need to do is we need to convert these numbers back into human readable text. So go ahead and make a function called log key with the parameter vk code. Windows API. What we got to do first is we have to open our log file, right? So we can do log file.open, and then gonna call it keylogger.txt just to make it simple, and don't want to like overwrite the Python one. And then same thing we did in the Python one where we had a to append, right? What we can do in C++, it's different, but it's the same concept. In case you skip the Python portion, basically what append mode does is it just makes it so no previous data is overwritten, right? You want to, when you have a file, if you're collecting data or you know, testing your keylogger, you might not want to lose that data. You might want to use it again even though you relaunch your keylogger. Okay, and then we're just going to make this look a little bit pretty, right? I want to add like just session headers so that when you're looking in that log file, it tells you that like a session just started, right? All right, cool. Very basic, right? So once the header is done, what we got to do is we need to set the boolean for is first key to false, because right here, this is if is first key. This is what this is. It's literally just saying if it's true, right? Because then once the if statement ends, it's gonna set it to false, so then this won't be true again. And I did accidentally set these as double quotes. If you caught that, I was like, why isn't this working? But yeah, it's because I had these as double quotes and not single. So basically, what do we have to do next? I mean, this is still inside of that log key function, but this is going to be quite a lot, right? Like, we got to try and figure out, like, because think about all the different cases, right? I mean, there's, if you have your shift key on, your caps lock, just everything, right? So basically, what we need to do is we need to check the modifier key states, right? So, like whether or not you have your, like I said, your shift down or caps lock or anything like that. We need to check these before we figure out what to write. All right, so what we want to do first is we want to check if shift is currently being held down. The problem is though, Windows has something called get async key state, right? This doesn't return a true or false. It returns a 16-bit number, which and where like these different bits within it mean different things, right? So if the most significant bit of that, which is bit 15, is 1, then the key is currently being pressed, right? So we need to find a way to check this bit. What we can do is we can use a bitwise AND with, okay, basically just like this, right? This will return 0x8000 if the key is being pressed, and 0x0000 if it's not. What is this, right? What you might ask, like, what is this? Basically in binary, that's this in binary. It's 16 bits, right? And in this case, only bit 15 is 1. And then this is known as a bitwise AND. Basically how it works is it compares each bit position, right? If both bits are 1, the result is 1. Otherwise, it's 0. So in this case, if the shift key is pressed, then this might return 0x8001, right? Which would mean that it's a non-zero. However, if shift is not pressed, it's probably just going to return 0x0000, which would mean false. And the reason that makes sense is in C++, any non-zero value is true, and then 0 is false. So long explanation, but that's how that works. I'll probably try and leave some sort of explanation in this code so you guys can kind of follow along and kind of understand. All right, next we have to check if caps lock is on, right? This one is very, very similar, except instead of using get async key state, we're getting key state. The main difference is this would be toggled, right? This async, you're currently holding it down, right? Whereas this has been pressed, so it's enabled, but it's not currently being held down. But yeah, this is very, very similar, except this is for toggle keys, like caps lock or nums lock. And then for toggle keys, we check the least significant bit, which is bit 0. So, for example, 0, that in binary is equal to that, basically, right? So only bit 0 is 1. If caps lock is on, bit 0 will equal 1. If caps lock is off, bit 0 will equal 0. It's that simple. Which, if it's a 0, it's false. If it's a 1, it's true. Pretty straightforward, just still kind of confusing because, you know, they got to make it. Now time for the best part. We got to convert those virtual key codes to readable characters. Yay. So now basically we're just going to use a ton of if-else statements to figure out which key is pressed. We're going to go ahead and check from most specific to least specific. We're going to go ahead and check from most specific to least specific. The order does actually matter. So we're going to start with the special controlled keys, right? These keys are ones that don't make visible characters, but we still want to log them. They're useful for understanding like what the user's doing, so like spaces, enter key, back, tab, etc. So this is where it gets so fun. Okay, so basically what this is saying, if the key that they press is a space in the log file, we're gonna put a space. That's it. So now, else if they hit the enter key, in this case, I want to add a timestamp, right? So in the log file, I'm going to actually create a new line because they're hitting the return key. So this will kind of help us format it so that when we're looking, it'll make it a bit simpler, right? So formatted time. Okay, so what this is going to do is it's going to put in the log file, it's going to make a new line when you hit enter, right? It's going to paste a new timestamp just for formatting help and so you can know when things are happening, and it's also going to let you know that somebody pressed enter. All right, so these are all of your special control keys, right? So what comes after these for specifics, we're going to go to letter keys, which are your A to Z keys, right? So virtual key codes like 0x41 through 0x5a are the letters A through Z, right? For example, 0x41 is, as I stated earlier, is equivalent to A. And then 0x42 is B, and then all the way up to Z is 0x5a. So what we want to do is we want to check if that code is in this range. So now we need to figure out whether it's uppercase or lowercase. This depends on both shift and caps lock, which is why we started off with that. So it's uppercase when shift is pressed and caps lock is off, or shift is not pressed and caps lock is on, right? Lowercase is the complete opposite. I'm not going to say that again because I'm probably going to say it wrong. So what we need to do is we need to make a Boolean, right? We want to check if it's uppercase. This is just going to be a true or false, right? All right, so what this is saying is it is uppercase if shift is pressed and caps lock is not on, or shift is not pressed and caps lock is on. Looks confusing. It's not. I mean, I'm sure if you guys are watching this video, you understand that. So, so now we go, if it is uppercase, right? VKCs for letters are already uppercase, like that 0x41 and that to 0x5a those are the ones for uppercase, right? Just by default. So we just cast it to a character and get the actual letter. Now, now we have to get it into a lowercase. So we go out, we do an else. To get lowercase, all we have to do is add 32 to that VKC, right? So why 32? In ASCII, A is 65. Like a capital A is 65, which is 0x41. And a lowercase a is 97, which is 0x61. And then 97 minus 65 for ASCII at least is 32. So lowercase is exactly 32 more than uppercase. Wow. So that's what we're going to do. All right, what next? We got to do our number keys, right? Virtual key codes are 0x30 through 0x39, I believe. These are numbers 0 through 9. So 0x30 is 0, 0x31 is 1. Pretty much just exactly what you'd expect, right? So just like we did with the letters, if you use shift on your number keys, not caps lock, doesn't affect it at all, but if you use shift and were to type 1, right, it'd put an exclamation point, things like that, right? So we need to see if shift is being held, right? So if shift is being held, we get a special character, not a number. Like shift 0 is like the closing parenthesis, shift 9 is the opening one, right? And then for ease, we're just going to use an array to map each number to its shift character, just make it easy on ourselves. The array, so we can just make an array, call it shift numbers, and then we can put one in for each number. So 0 is the closing bracket, 1 is the exclamation point, etc. So after you write them all out, that's it. And then we need to convert the VKC to an array index. So we just need to make an index. So for example, if the key they pressed is 0x31, which is equivalent to 1, right? If you subtract 0x30, or index 1. So then you can just, to the log file, all you got to do is shift numbers and then the index, and then it'll just put that, whatever the corresponding, so basically if shift is pressed, whatever key is pressed with shift, it'll correspond to in the character array, whichever one. So basically, if shift is pressed and you hit a number key, then it'll correspond to whatever special character is supposed to be there, and that's what it'll show in the log file. All right, cool. So now we have to make an else. So let's say that there's no shift being pressed, right? That's what this else would be. So it's just the output. You just have to output the number as is. The VKC is the same as the ASCII code for the number, which is really nice. So like 0x30 is equivalent to 48, and 48 in ASCII is 0. So to that log file, we can just convert it to a character. Okay, so what's next, right? Now this is where the fun begins. This is where I get to sit here for 3 hours typing. So punctuation and special characters make different characters with and without shift, just like plenty of the other ones. Windows has specific VKCs for these, right? So start an else if. So what these numbers are, it's just the VKCs. It's the equivalent, right? So the semicolon and colon key, without shift, it's a semicolon. With a shift, it's a colon, right? So when we go to log this, we're going to see if shift is pressed, right? And what this question mark is, it's a ternary operator. It's basically like a mini if-else statement. If shift is pressed, then it's a colon, right? If shift is pressed, it's a colon. Else, it's a semicolon, right? All right, so here's all of them laid out, right? Please feel free to copy these from the description. It's going to be a heck of a lot easier for you. So yeah, now that we have those, what's next? Okay, so next we have another relatively easy one. We have the function keys, right? So let's do it in a fun way. So for function keys, VKF1 through VKF12 are the Windows constants for the function keys, right? They're sequential, so we're able to check if the code is in this range. So just like we did it for the letters and the numbers, so basically we're trying to figure out which function key was pressed, right? VKF1 is the first one, right? So we subtract it to get the offset, which because it's 0 to 11 technically. Then we add 1 to the actual number. So okay, so basically we can do it just like we did with the letters and the other numbers. Because, you know, it's going to have to go 0 to 11. It can't go like 1 to 12. We're just going to make this simple, right? So what we're going to do is if you press F5, it'll take your key and then it'll subtract VK underscore F1, and then that'll give you your thing. So if you press F5, the offset will be 4, and then we're going to add 1 here, right? So it'll be 5. Then we can put this, just pretend it's, you know, it's just the way to format our F key. We're going to put time and then put in brackets the number. So then it would, if you press F5, it would say F5. What next? We got arrow keys. So these are navigation keys. These are done literally the exact same as all of the other ones. There's really nothing special about the arrow keys. I mean, it's done the exact same way as all the other ones. I'm not going to have create a new line or anything. I'm just going to be basic just like that, right? Okay. So what next? Modifier keys, right? Windows has separate key codes for left and right versions of modifier keys. So we're going to check these before the generic version. By left and right versions, I mean you have a left shift and a right shift. You have a left control, left Windows key, right Windows key, etc. So basically what this is saying is if the key is equal to 160 or 0x80, basically these are equivalent, right? This is in decimal, this is in hex. So, and now I do this for every single other key. So give me a minute. All right, there we go. Pretty straightforward, right? And nobody's ever going to expect you to memorize all of these decimal and hexadecimal values and just everything corresponding. Everybody uses documentation for this. Nobody knows. You Google it. You figure it out, right? All right, and now we go to lock keys and special keys, right? So, for example, we're going to go to like the caps lock key. So what we're going to do is get formatted time, and we're just literally going to put right here, we're just going to put caps lock. There you go. And now we're going to have to do this for numlock, scroll lock, then the left Windows key, right Windows key, etc. All right, and finally, we're going to go to our final thing, which is like we're pretty close. The unknown and unhandled keys. So like, what if somebody hits a key that we haven't accounted for? Like they have some really weird key. So like it could be just some special key, like volume toggle button, right? I didn't want to try and find what that would be, right? Because it might not even exist. Or it could be a key on an international keyboard, or like some keyboard has invent some new key. I don't know. It doesn't matter. So this might happen. So what we're going to do is we're going to log in both decimal and hex so that we can look it up if it's ever needed in the future. So we're going to create we're going to create the else, and then we're going to put the time. All right, boom, and there you go. It's kind of long, but that's it. So basically, in the log file, you're gonna put the formatted time. So what we had earlier, what we've been doing this entire time, and then it's gonna say unknown key, and then it's gonna say the VKC, and then it's going to output the value in hex format, and then it's going to do the same thing with decimal. And then this is just going to format it to try and make it look pretty. So finally, we're done writing that all out. We're going to save the data to the disk. This is really, really simple. We're going to do logfile.flush. What this does is it forces Windows to write the data to the disk right away. Without this, the data could stay in memory and get lost in case the program crashes. So it's just a safety check. It's basically just like hitting like Control S or save when you're in Notepad or whatever. And then we're going to do logfile.close. So we're basically saving it, and then we're closing the log file. And then close, it just, we'll free up system resources and just ensure that the data is written immediately. Finally done with that, right? So now we need the keyboard hook callback function. That's just what we're going to call it. It's very long, but it's just what I'm going to call it. Right, so now we need a callback function that will be called by Windows whenever we press a key, right? The actual, another core of this program, right? Basically, right? Press a key. This function will be called, and then it will receive the VKC, the virtual key code, and then it'll process it, right? It will then call the log key function that we just made to log the keystroke. Then we'll have it return the result so that Windows knows that we process that message, and then it can continue processing the next message. So basically, this function is a keyboard hook callback. Windows will automatically call it every single time a keyboard event happens, like pressing or releasing a key. Encode tells you what you should do, like whether or not you should process the event. WPRM tells you what kind of keyboard event happened. LPRM is like a pointer to a structure that contains like detailed information about that key. If encode is greater than or equal to 0, it means that we should process this. For WPRM, there's both key down and key up. For this, key up isn't going to help us at all because we don't have a key release in our log file or anything. We only have press down, so we aren't going to have to worry about that. So right here, if WPRM is equal to key down, so we're just going to ignore everything else. This is basically just saying we got to treat this memory as a KBDLL hook struct. All right, so we have to get the virtual key code from the structure so we know which key was pressed. This is the number that tells us which key is pressed. So just like we've been doing. All right, and then all we're going to do. So basically, this line is converting LPRM into a pointer to a KBDLL hook struct. Windows passes LPRM as a generic value. C++ has no idea what kind of data it points to. In a low-level keyboard hook, though, LPRM actually points to this, which also contains information about the key event. By casting it, which is typecasting, we're telling C++ to treat that memory as this, so that we can access fields like VKC. This data exists. We're not creating or copying anything. We're just interpreting the memory correctly. All right. We also have to call next hook X and pass all of our parameters so that Windows knows that we process the message and it can continue processing the message further, or the next message. Fantastic. Main function. We're almost done. We're getting very close. Every C++ program must have a main function, right? Our main function will need to do the following. It'll need to set up the keyboard hook, run a message loop to keep that hook active, and then clean up the program when it exits, right? So we're just going to start to get out of the way to create a function that'll handle the console close events, right? So we're going to call it console handler. We're going to open the log file, which will be keylogger.txt. And then we're going to append. So because if it just randomly closes out of nowhere, the program won't be running to actually know, right? It won't, when you close it instantly, it closes, right? It's not going to be able to then add. It's not gonna like take a second. It's just gonna close, right? So if the log file's open, we're essentially gonna do the very similar thing to what we did at the beginning, where we had session begin, except we're just gonna be doing it with session ended, right? And then we're gonna flush it and we're gonna close it just like we did previously. And then we also need to uninstall the keyboard hook. And then we want to return true. All right, sorry about that. Now we're actually going to get to our main function. So I want to print a little welcome message in the console. Not the log. We're done with that log part for now. But I want to print like welcome in the console. So we got to let the user know that the program started. So welcome to your keylogger. Close the window to exit. Right? Pretty straightforward. And then we're going to go all keystrokes will be logged to the keylogger.txt file, right? Pretty simple. And then we got to make sure we set up that console control handler, console handler, and then true. So what this will do is this line, this is going to watch and catch any like window close events in case the program closes. Okay, what now? Well, we need to get a handle to our own executable, right? Basically we want Windows to know which program is installing the hook. Null here means get handle to the current module, which is this program that's running, right? Okay, so basically we're gonna install the keyboard hook. This is like quote unquote magic that lets us like intercept the keyboard input, right? So keyboard hook. Alright, so basically what this is, the first parameter is the hook type, right? Low-level keyboard. The second is our callback function. The third is a module handle. And then the fourth is just saying hook all threads, just so it's just system-wide. Okay, so now we need to make sure that this keyboard hook was actually installed successfully. If it fails, then it'll return null. Okay, so basically, if keyboard hook is equal to null, if for some reason it fails, right, it's going to print out these errors. However, if it's not null, then the keyboard hook was successful. Okay, so basically our function gets messages from the message queue and processes them, right? It waits until a message arrives. We're going to create a loop that continues until get message returns 0, which is, you know, just what we'll have, which will just mean to quit. Windows uses a message-based architecture. So basically we're going to return value from get message, and then this is just going to be the structure to hold message information. Okay, so as I said, if get message returns 0, it's time to exit. If it returns -1, there was an error. And if it returns any value greater than 0, it means the message was successfully received. So, alright, and then here we're just going to check for errors, right? Alright, and then we're going to send the message to the correct window procedure. Beautiful. Alright, and then finally, before exiting, we have to uninstall the hook. If not, the hook will stay active, even after the program exits, which could cause problems later on. So we're going to write a session end marker to the file and then close it. Alright, and there we go. Finally, we have to unhook. Alright, and then just return 0. And that should be all done. Alright, and it looks like we don't see any errors down there, so let's go ahead and run this. Go to PowerShell and run it as administrator. I'm on a VM right now because I've already done this all on my host computer, so it's going to be a lot easier just in the VM so that I can actually show you guys the process. If you're on Linux, because you can do this for both Windows and Linux, I'm doing this specifically for Windows, but it's a very similar process. If you're on Linux, just with whatever package manager you're using, just install GCC. But on Windows, we got to do some fancy stuff because, you know, Windows is goofy. There's a package manager on Windows called Winget. I think it's Winget, not Wing It or whatever. I don't know how to say it. It doesn't really matter. So what we're gonna do, that's the package manager similar to what you would have on like a Linux distribution, like DNF, APT, like whatever, yum. Winget should come pre-installed on most Windows operating systems, like especially Windows 11. Like this is a VM and it had it. My host machine, Windows 10, I believe it has it. But if you don't, you can just go to I'm sure like aka.ms/winget or whatever, and I'm sure it'll just show you the download. So what we can go ahead and do is we can type winget search MinGW. MinGW basically just contains a bunch of tools. One of those being the GNU compiler collection, which is the GCC, which is what we need to compile the C++ application. So I'm just getting this set up now. After this, you can type winget install, and then we're just going to choose this top one, so you can just copy it, and there you go. Once it installs, it should say successfully installed. Because I am on a VM, I'm not properly authenticated with Microsoft Store, so I will get this. So I will get this failed when searching source. Results will not be included. MS Store. So I will also have to add source winget. You might have to as well. I don't know. So just keep in mind if you add that source winget at the end. All right. So to compile, you want to go to that folder, and then you want to type G++, the C++ file name, and then -o, so that the output is going to be, I'm just going to give it the name keylogger.exe, right? And then you can go ahead and run it, and there you go. It works just as it should. So that's how you compile it. All right, so I'm gonna go ahead and I'm gonna run this, right? Now it's recording. So if I open Notepad and I'm like, hello. All right, and then say I wanted to go to facebook.com and my username was Charlie and my password was subscribe, right? Okay, so now I can go ahead and I can close this, right? So in keylogger.txt, I can go ahead and close this. Keylogger.txt. This is what it would show. So session started, and I open Notepad, right? And I hit caps lock. When I opened Notepad for some reason, I hit enter, and then I was holding left shift to type that H, and then LO, and then left shift exclamation point, and then I click left shift again, right? And then left shift for that capital U in username. So you can kind of look, it'll kind of like sort things out. So I press enter and I type facebook.com, and then password, because I hit backspace, it would break up. There is ways to make this like a lot more like organized and sorted, because you could just have it so like the backspace actually removes a backspace. If you guys want me to make a video on that too, I can. But this was just like, I would rather it log that it said backspace, because you could write like a simple Python script or whatever. But yeah, here looks pretty solid to me. This is exactly what I think you guys need. In 364 lines, a full C++ keylogger. And honestly, it's not too bad. I think it's pretty solid. I mean, it has room for improvement some places, but it's, it's solid. So I think this recording took me about an hour and 50 minutes, maybe. I'll probably cut it down to a lot shorter, but yeah, if you liked and you think you learned something, like and subscribe. If you have any recommendations, I'll build pretty much anything. I really like building this one. It was a ton of fun, so just let me know. See you guys in the next one.